Bismillahirrahmanirrahim. Greetings. Paradox is an absurd statement which is contradictory to the real world application. Now in this lecture I'm going to talk about one of the Zeno's paradox, and it does have application, as a matter of fact, in mathematics. One of which is about the sequence of partial sum that we will see in this lecture. I also intend, in this lecture, I will be waving my hand and assuming that some of the terminologies and symbols you are familiar with, but the very same terminology and symbols I will be explaining further when, as I intend to upload maybe 2 or 3 more video lectures about series and sequences. All of them that I'm uploading are in the kind of basic algebra level, and I do not go too deep into that, as it is series and sequences are part of the curriculum of calculus. So let's get started, shall we? Now, an argument took place between a hare and a rabbit. Now, hare running 1 mile per hour, that is the speed, brag about and say to the rabbit that I can run twice as fast as you run, and I can beat you in every race. You got the picture so far. Now the rabbit, being educated, he says that if you give me 1 mile head start, I bet you will never be able to catch me. Now, hare, being confident that will win the race, no matter what, in a sense in that case, he puts a big amount of money on betting. So let's see which one of them will win the race. All right. Now I have put in this one in writing. Let me start. Let me go ahead and zoom it. Now the scenario is this. Rabbit is 1 mile ahead of a hare when the race starts. And when the race starts, I keep repeating that, but because we will see that, and it's very important in that case, is that the time expires the same for both of them. Now, at the end of the 1 hour, the hare will be the same spot, the same point that the rabbit was an hour ago. And at that, because the time expiring the same for both of them, and the rate of the rabbit being 1 mile per hour. Let's talk about, as I already mentioned, about velocity, because velocity has direction. So let's say we are going to certain direction and on in a straight line. That's what the race is taking place. Now, going back to that, within that 1 hour, the rabbit will be how much? Will be half a mile ahead. Why? Because the rate of that is half a mile per hour, and half a mile per hour is the rate times 1 hour. The distance will be what? The distance will be 1/2 of a mile. So the rabbit will be 1/2 of a mile ahead. So the rabbit will be here, and the hare will be here. So now the location is changed. Is that right? The hare will be here. And then what happened after that? In order for the hare to catch the rabbit, that is half a mile. His velocity being 1 mile per hour, so it takes him half an hour to reach that point. Is that right? And within that 1/2 an hour, because the time expired the same for both of them, the rabbit has gone 1/4 of a mile ahead. Why? Because his velocity is half a mile per hour, and within half an hour, 1/2 times 1/2 is 1/4, so the distance will be 1/4 what of a mile ahead. 1/2 is velocity miles per hour, within, and the time is half an hour, so half times half is 1/4, so the distance will be 1/4. Now the rabbit is 1/4 ahead of hare. So again, from the beginning, it was first 1 mile ahead when the race started. Then at the end of the 1 hour, it was half a mile away, ahead. Then at that half an hour later, it will be 1/4 of a mile away, and so on and so forth. Now I have written this just for those that you like to take notes. Let me now take that one off. And now, as you notice here, I have written that the velocity of the hare is 1 mile per hour. Velocity of rabbit is half a mile per hour. All right. Now, the scenario of that here is said, start for the distance that is covered is 1, then 1/2, then 1/4. Is that right? Then 1/8, then 1/16, and so on. This is the distance that the hare is covering as he's chasing the rabbit. Is that right? So this infinite number of terms that you notice, I use this notation. This is summation notation, and that end up with an infinite series. Now about this notation and the infinite series, again I'm waving my hand, but I will be uploading, and all of them I will be explaining in more detail. Now, to a physicist, now listen to this carefully. To a physicist, the hare will catch the rabbit. So to a physicist, the hare will win the race. To a mathematician, the rabbit will win the race. Now, lo and behold, let's see which one of them will win the race. Okay then, now, what do you think? Whom do you think will win this race? So let's find out. Now, in order to expand it a little bit further, no need, but just for extra, as I said, I'm uploading this for at the basic algebra level student audience. So to be more explicit, when the race started, the rabbit is 1 mile ahead. You see that? So the distance between hare and rabbit is 1 mile. So then I separated that one so that you can see that when at the end of 1 hour, what happens? The hare will be here 1 hour later, and the rabbit will be half a mile ahead. Is that right? Why half a mile again? This is half a mile. Half a mile ahead. Because of what? Because velocity, distance equal to velocity times time. Velocity of the rabbit is what? Half a mile per hour. Is that right? So at 1 hour, the distance will be half. So it's half a mile, now is ahead. Before was 1 mile ahead, now is half a mile ahead. Then, in order for the hare to catch the rabbit, he has to cover this distance. Is that right? Because the rate of the running of the hare is 1 mile per hour, so it takes him half an hour to reach the same place that the rabbit was. Is that right? That within that period of time, half an hour, then half an hour, because the velocity of the rabbit is half a mile per hour, times the time, which is half an hour, so half times half is 1/4. Therefore, the distance that the rabbit will cover will be 1/4 of a mile. So now the rabbit is 1/4 of a mile ahead of the hare. Do you follow me? So if you want to write it, now the hare is here, and the rabbit is 1/4 of a mile ahead of it. So the rabbit is here, and this will be 1/4 of a mile. Do you follow me so far? Okay then, now let me see, let me put it, I made a chart also for that, for those that they like to take a note. Now this is the chart of that scenario, huh? Now, the hair at the when after at the end of 1 hour, the hair will be what? Will be the same place as the rabbit was, which is what? 1 mile. Is that right? The distance. So the hair the hair has covered how much? 1 mile. At the end of 1 hour, he has covered 1 mile because his velocity is 1 mile per hour. Now the time is expiring the same for both of them. So for when the time is 1 hour, the velocity of the rabbit is half a mile per hour. Therefore, what will be what? The time will be, for the time to determine is what? Velocity times time. The time is 1 hour, velocity is half a miles per hour. So the distance that the rabbit has covered is half a mile. You follow me so far? Now the hare should cover half a mile. Is that right? His velocity is 1 mile per hour. So he will take him half an hour to cover that. Is that right? Because what? Because velocity times time equals to the distance. So when the distance is 1/2, the velocity is what? Is same 1 mile per hour. So the time for the hare to catch that point that the rabbit was will be half an hour. Now during that half an hour, the time for the rabbit, the velocity of rabbit being half a mile per hour, so half a mile per hour times the time being half, dropping the units, half times half is 1/4. Now the distance that the rabbit has covered during that period of time will be 1/4 of a mile. And this procedure will follow and continue in a reality forever. Now, let's see which one of them will win now. Which will be the win. Now let me zoom this one and talk about it. Now, to a physicist, the hare will win the race. To a mathematician, the rabbit will win the race. Now look what happens. Let's first talk about the physicist view of point. Let's say the distance that it takes for the hare to catch the rabbit to be dh, or maybe x you can put of that. I'll go over that. Let's say it's dh, which means the distance that the hare will cover, that he catch the rabbit for that distance. Then, because the time expiring the same for both of them, and the rabbit has started 1 mile head of the time, 1 mile head, so the distance that the rabbit has covered during that period of time will be distance of hare minus 1, less 1. Do you follow me? Whatever the distance that the hare has covered to catch the rabbit, less 1 will be the distance that the rabbit has covered. Is that right? Now the time expiring the same for both of them. So distance equal to rate times time, time equal distance divided by rate, distance divided by velocity. So from that we can set up the equation, mathematical equation, and find out at what point the hare will catch the rabbit. Let's see now. Let me now zoom it up and and go over that, the mathematical, excuse me, let me take this one off. Okay. Okay, now I have written, I read it for you, to a physicist. Let d sub h to be the distance covered by the hair. When? You see, I wrote the when in red because I will be talking about what time is related. When indicates time. When hair catches the rabbit. Is that right? Then, with respect, WR means with respect. With respect to the distance that the hair covered, the distance covered by the rabbit will be distance of hair minus 1. Is that right? Less 1. And the time, as I already mentioned, I keep repeating that, the time expires the same for both of hair and rabbit. Now, distance divided by velocity is equal to time for the hair. And distance of hair less 1, which is the distance of rabbit, divided by his velocity is equal to the time that for the rabbit to be caught by the hair. Is that right? Now these two times are same. So that means this and this, another way to represent the time, is that right? Distance divided by rate, I drop the units. Distance divided by rate, which is velocity, I drop the units. And then the simple arithmetic, multiply numerator and denominator of this one by 2. So we end up with this equation, and then add to both sides negative 2 the distance of hair. You get negative dh equal to what? Negative 2. And then multiply both sides by negative 1. You end up with distance that hair covers to catch the hair, to rabbit, it will be 2 miles. Now, the second part of it, I put x instead of distance of hair, d sub h. So I said let x be the place that the location that the hair will catch the rabbit. And then I went through exactly the same thing, which is what distance divided by velocity equals to the time, and distance is this, and exactly the same as this, but instead of dh, I put x. You follow me so far? Okay then, now let's see, so this is the way that a physicist, according to a physicist, the hare has catched the rabbit, so the hare has won the race. Now let's see what will be the philosophy of a mathematician. Why does he say that the rabbit is the winner? So let's see what will be that one. Let me see if that is Zoom. Yeah. Okay, now, to a mathematician, this will happen. For the hare, 1 mile, then 1.5 to catch the rabbit, so 1 plus 1.5, let's put comma. Then comma 1 plus 1/2 plus 1/4, comma 1 plus 1/2 plus 1/4 plus 1/8, comma, and so on and so forth. And this ends up to an infinite series. That again, I repeat that, if you are not familiar with this notation, and also with the terminology of the infinite series, I will be uploading a few lectures about that shortly. Now, this ends up to, this will be the corresponding set of the partial sum, which we'll call it the sequence. So it will be the sequence of the partial sum of this series. All right? So that sequence will be 1, then 1 plus 1 half, then 1 plus 1 half plus 1/4. Is that right? That is the sequence that the hair is covering, the distances that the hair is covering in his chase about the rabbit. So this sequence is this sequence is the sequence of partial sum of this series. Do you follow me? And then the limit of this sequence is 2. But 2 is not belong in this set. Do you follow me? So 2 in reality is a least upper bound of this infinite series, but is not belong to this set. So in that regard, with that explanation, the mathematician says that the rabbit is the winner. So let me now zoom it back and explain it a bit more. Now the situation is very interesting, isn't it? So what happened here is that, you may say that the pi, for example, the digits of the pi goes forever, but the number pi does not have a least upper bound. There is no least upper bound for the number pi. It's an irrational number. But here, 2 is the least upper bound. 2 is the limit of the sequence of partial sum. But the pi does not have a limit. The digits keep repeating and there is no limit. There is no end for that. But in this scenario, the 2 is the limit, but the mathematician is correct because the 2 is not belong to the sequence of partial sum. Now this is a fairy tale story, but the second part is a real story, the true story. Is a computer scientist from Casablanca, Morocco, by the name Zeno G. I don't know how to pronounce her last name, is a French name. Now, she is neither mathematician nor physicist. So as a computer scientist, she wrote a program. All right. Now look what happened for the program she wrote. She used 1 mile of this paper. 1 mile, one next to that, next to that, next to that. You can imagine how many number of them it is. It's a simple arithmetic. You can find out for yourself. If you round it off the length of that to be 10 inch, and then find out how many of them she used, both sides in fact, so that she can write. So what she did, she went through the sequence of partial sum. So 1, then 1 plus 1 half, comma, 1 plus 1 half plus 1/4, comma, 1 plus 1 half plus 1/4 plus 1/8, comma, 1 plus 1 half plus 1/4 plus 1/8 plus 1/16, and so on and so forth. So in one page, you can write maybe 50 lines. Is that right? In one page of that. Write all of them in line, second line, third line, and so on. Maybe about 50. And the other side, another 50 is 100. 110 inch long. Is that right? Now, if we put them all next to each other as a line, linear, that will be definitely more than 1 mile, maybe close to 10 miles. And still, you see how many calculations she has to go through. 1 plus 1 half plus 1 comma, 1 plus 1 half plus 1/4, comma, 1 plus 1 half plus 1/4 plus 1/8, and so on and so forth. And you put them all in a one line, will be close maybe to 10 miles, and still the rabbit, the hare could not catch the rabbit. It still didn't end up to 2. So the mathematician was correct to say that the 2 is not belong to the set of the sequence of partial sum. Therefore, 2 is the limit in fact. Therefore, the rabbit is the winner. Lo and behold, It's very, very interesting, isn't it? Okay then, I thank you for watching. Today is the 5th of the January 2025. I wish you all very happy new year, and I wish you all very prosperous and healthy 2025. Again, thank you for watching, and please stay safe. So long.